You open a pull request, and after 2 minutes you realize you're just pretending to understand it. You scroll up, read again, and still nothing. It's not that the code is wrong, it's not even that bad. So why does it feel so painful? The answer has nothing to do with programming, it has to do with how your brain works. Let me show you what's actually happening. Let's be honest, we've all been there. You get a notification, a teammate has requested your review. You click the link, the page loads, and then you see it. You start scrolling, trying to piece together the story of this change. Long functions, cryptic file names, logic that jumps from one place to another with no clear path to follow. Comments from other reviewers start arriving. Maybe use a different variable name here. This seems inefficient. No further context. You feel your focus slipping, and the familiar thought starts creeping in. Am I just not experienced enough to follow this? It's not about skill, but something is going wrong. And here's something interesting. Think about it. What's actually the hardest part of reviewing a large PR? You may realize that the most time-consuming part of reviewing code isn't finding bugs, it isn't critiquing architecture, it's simply understanding the change. The single biggest bottleneck, the greatest source of the pain, is the sheer mental effort required to load the context of a change into your brain. And with AI generating more code than ever, the problem is only getting bigger. These tools can generate vast amounts of code in seconds. The bottleneck has shifted from writing code to reading it. So the pain you feel isn't a weakness. It's you hitting a physical biological wall. And that wall has a name. That wall is called cognitive load. First described by psychologist John Sweller in the 80s, the idea is straightforward. Your working memory, the mental space where you actually think, has a hard limit. Think of it like RAM. When you try to load too much at once, the system slows down, and eventually it crashes. There are different types of cognitive load, but the one that matters here is the useless one, the load created by how code is written. Extraneous load is the mental effort wasted not on the problem, but on how the problem is presented. Deciphering a poorly named variable, untangling a function that does 6 different things, following logic that jumps between unrelated concerns. The pain of code review is almost entirely caused by extraneous load. Cognitive science gives us a number for this limit. You may have heard of Miller's law, the idea that working memory holds roughly 7 chunks at once. More recent research put that number closer to 4 or 5. But here is what matters more than the number. A chunk isn't a line of code, it's whatever your brain treats as one unit. A well-named function, one chunk. 50-line function doing 3 different things, many chunks. And your brain has to build them up first. As you read this, your brain starts tracking chunks. The best way to learn this is to try it. Pause the video, find the logical chunks, and then we'll walk through the function together. Chunk 1. What are the conditions for processing this order? There's a big if statement, OK. Chunk 2. The user must be an admin. Chunk 3. Or have an active subscription. Chunk 4. And more than 10 logins. Chunk 5. And the order can be flagged. Your working memory is already full, and you haven't even reached the actual logic yet. And then come the discount rules, the price thresholds, the category check, the notification step, Your brain isn't failing, the code is failing your brain. It's creating an extraneous load, forcing you to spend all your mental energy just deciphering the structure, leaving nothing for actually reviewing it. By the way, this channel is focused on how experienced engineers think, architecture, trade-offs, and real-world systems. If you are looking for deeper explanations, not just tutorials, that's what you'll find on my channel. Same logic, same outcome, but now your brain processes. Is this a privileged user? One chunk. Is this order processable? One chunk. Calculate total? One chunk. Finalize? One chunk. We just took 5 confusing conditions and compressed them into 2 readable ones. That compression, that's chunking working in your favor. And this is what clean code principles are actually about. Small functions, clear naming, separation of concerns. They are not style preferences. They exist because your brain has limits, and good code respects those limits. The next time a code review feels painful, don't just ask, is this code correct? Ask, is this code readable for a human mind? Because that's where most complexity actually comes from. Not difficult problems, not bad developers, just code that asks more of the brain than the brain was ever designed to give. That's the shift from blaming yourself to understanding the system. And there is one more layer worth exploring, because it turns out not everyone is working with the same buffer size. Some people process complexity differently, and that changes how teams should work. See you in the next video.